Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is operator overloading. Before proceeding, make sure that you have already watched these other videos first. Programming languages distinguish their data types as being either a value type or a reference type. A value type is something like C++'s int. There's nothing special about either of these threes, nothing to connect it to the other three, other than they both happen to have the same value. They're both just two values. A value type usually only needs a small amount of computer memory, making it fast to copy them around as needed. Sometimes copied by a copy constructor, or sometimes copied by directly passing it as a parameter value. When comparing two expressions, a value type cares about the equality of those two values. On the other hand, a C++ object is often used as a reference type. The reference type might still contain numeric data, but it treats that data as some kind of payload which it owns and controls. Here are two object instances. Even though they both contain the same quantity, both threes, we consider these two objects to be two distinct, different things. Think of these two reference-typed objects as each having its own identity. In fact, we often reinforce that concept by programming some kind of identity member. A reference type's data is often structured, complicated, and big. So a programmer might not even allow it to be copied from one object to another. Or maybe he provides that copying capability, but with an understanding that it may be a costly, time-consuming operation. To avoid copying a reference-typed object, use some form of indirection. In particular, when you need to provide your object as input to some function, program that function to get the object passed in as a pointer variable. Or to get the object passed in as a reference variable. Now you see why we call these reference types. When comparing two reference-typed variables, we usually interpret equality to mean that they have the same identity. It's not enough for them to only happen to have similarly valued data in their members. One method of using identity as a measure of equality would be to test whether those two pointer variables are both pointing at the same memory address. C++ gives you the ability to program a custom type, a class, which would normally act as a reference type, but writes some more programming, which lets you use it as a value type. The mechanism to do this is the programming of custom operator overloads. For example, clients often expect that a value type, like this int, would have the ability to add two of its values together. Now let's say you're programming a custom type for representing a complex number. You need to implement an operator overload whose name is operator followed by the symbol that you're defining, in this case, a plus symbol. You could have written the operator overload as a global function, accepting left-hand side and right-hand side operands as its two parameters. But we've written this as a member function. So the member function's this pointer will be pointing at the left-hand side object, OLHS. The compiler automatically passes in the right-hand side object as a parameter. Recall that in member functions, you don't need to type the dereferencing of a this pointer, because the compiler will assume that's what you mean. This parameter's type must be a const reference, because the right-hand side might have been a compiler temporary, which cannot be written to. If you were to write an equality operator overload, it would look much like this one, except that it would calculate and return a Boolean. This client code demonstrates some more ability that a client expects from a value type. Be careful to remember that the equals symbol is used for either copy construction or assignment, depending on its context. If you don't program your own version of these two functions, then the compiler automatically provides a default version of them, but the compiler's implementation only does a shallow bitwise copying of members. For a simple class, like our complex number class, that would be good enough. But it's not good enough for many other classes, especially classes defined with data members pointing to dynamically allocated memory. So, generally speaking, if you want your custom type to be a value type, then you would need to program your own implementations of copy construction and assignment. Here's what the syntax looks like for assignment. Once again, we've written this as a member function. So the member function's this pointer is pointing at the destination object being assigned to, with the assignment's right-hand side automatically passed in as a parameter. When client code uses an assignment statement, it usually only cares about the side effect of something being assigned to. But technically, the C++ language requires that all assignments actually do return something. They return a reference to the thing that was just assigned to. So you must do likewise when you program your operator overload function. Although weird, it is legal for client code to assign something to itself. So the first code line of an assignment operator overload should catch that possibility. If your custom class derives from some base class, then your assignment operator overload should either assign the base class's members for it, or else manually call the base class's assignment operator. When we type a function call in our source code, we're typing a pair of parentheses. Technically speaking, those parentheses symbols are another operator, and even that operator could be overloaded. Notice how this client code has written something that looks somewhat like an ordinary function call, but instead of writing some function's name, This client programmer has written his variable name in its place. When this code is run, the function call notation will trigger your implementation of an overloaded function call operator. Recall that a unary operator, such as the increment operator, does two things at the same time, both accessing the value of some variable and changing its value. When the unary operator is written in prefix form, the changing happens before the accessing. If the client programs it as a postfix operator, then the accessing happens first, before the changing. When you overload a unary operator like incrementing, you should implement both forms. The compiler expects you to distinguish between them by typing an unused dummy parameter when you're implementing the postfix case. The array indexing operator can be overloaded, as shown here. Recall that overloading can discriminate between two member functions where the only difference is that one of them is a const member function. When you overload indexing operators, take advantage of that ability. If the CRArray object is a constant variable, then the const member function will be used, which returns access to the collection item in the form of a constant reference. But if the CRArray is not a constant, then the other member function will be used, which more liberally provides item access in the form of a reference that can be written to. Sometimes your client might want both less than and greater than operators, but it would seem unnecessarily redundant to program both of them since their implementations would be identical except for being opposites of each other. Therefore, there's a built-in utility header which contains some code looking like this. Your client could include that header and a relops namespace to enable an option where the C++ language would then provide a few of the operator overload functions for you, defined by the language in terms of equality and less than operators. You need to have programmed the overloading of equality and less than yourself. The operators provided by that header are greater than, less than or equal, greater than or equal, and not equal.